Hi, friends. It is a pleasure to be here with a new lecture from particle physics. In today's lecture, I will discuss about the Higgs boson and its discovery and its properties. My today lecture will be fully based on Higgs boson. The idea of Higgs boson came from those times when the particle physicists started to answer different kinds of questions regarding the subatomic particle present in atoms. This is a picture of a standard model of particle physics. In a standard model of particle physics, there are different particles, and every particle have different properties and different masses and different spins. In the topmost, you are seeing the family of quarks. There are six quarks: up, down, charm, strange, top, bottom. And these six quarks have different spins and different masses. On the other end, in the bottom, there are the leptons families. In leptons families, there are also six quark. There are also six particle: electron, mu, tau, electron neutrinos, mu neutrinos, and tau neutrinos. On the right side, you are seeing four particles, and these particles are called bosons family. These particles have certain properties, and they transpose and they transfer forces. There are four basic forces in physics: electric force, magnetic force, and we combine these two forces and gave it one name, which is known as electromagnetic force, and a strong force and nuclear force and gravitational. And electromagnetic force is transferred by the photon, which is the particle of light, and light has a nature of electromagnetic nature. Gluons are those particles which carry a strong nuclear force, and they attach the quarks inside the atoms, and that's why our nucleus is bounded by this gluons. On the bottom, W and Z bosons carry electro weak force, weak nuclear force, and this weak nuclear force is a force which is responsible for the radioactive decays. And because of this electro weak force, sun is able to burn hydrogen into helium and provide energy. These four particles carries forces. But when particle physicists start to answer the question about these fundamental particles, that we know every mass, every matter is composed of subatomic particles, which are known as atoms. If we look at inside the atom, then we find out that there are further particles which are constituent of this atom. These are electron, proton, or neutron. Now, when you look at the electron, then you figure out that electron belongs to the standard model of particle physics, and electron is a negative charge. But when they start their journey into more depth, then they find that proton and neutron, we thought that they are the fundamental particle which made up nucleus of the atom, is not. These both particles are not the fundamental particles, but proton and neutron themselves are made up of from another particle which are known as quarks. And proton is two half quarks and one round quarks. When two half quarks and one round quarks are gluoned by the gluons, Then by the strong nuclear force, then they made up another particle which is known as a proton. On the other hand, when two down quarks and one half quarks will combine together by the help of a strong nuclear force, then they made another particle which is known as neutron, which is electrically neutral. This was the discovery of the particle physicist. Now they started to know about the masses of these particles, where the masses of these particles, where they get their masses, the quarks family, leptons family, and bosons family, where the masses of these particles actually generated, actually came from. Then they give, let me show you the simplest way of understanding what is actually mass. Mass, when you apply a force into an object, that resistance that object feel is actually the mass of that object. That resistance define the mass of that object. Now they were, particle physicists were interested to know the generation, that where these particles get their masses. And a particle physicist named Petro Higgs, he he monitored the masses of these particles, and he was interested to know about the masses, where these particles get their masses. And in 1964 he proposed a theory, and in his theory, his theory was completely full of mathematics formulas. But his theory was not recognized one of the most important theory in the field of particle physics in that time, because the topmost people thought that maybe it is silly that Petro Higgs shown us how it is possible. Then this is the world of physics. In the world of physics, we do experiment and we get the result. Now Petro Higgs discovered, in his theory he presented a field which is known as Higgs field. Now Higgs boson is a particle according to Petro Higgs theorem or theory, and this particle is capable of generating the field which is known as Higgs field. Electromagnetic, we have different kinds of field, that is electromagnetic field, a strong nuclear field which is created by the gluons, and we have gravitational field. In the same way, this Higgs boson also generate a field into a space, and that field is known as Higgs field. Now it is, in this slide you see an area which is covered with sand. To show you the basic idea of Higgs field, first you have the idea to get what happens if you are going into this sand. When you move into this sand, then you feel a resistance. Where this resistance is being generated, this resistance is being generated by this sand. And in this field, and if you are going to the field of sand, then you feel a resistance. That resistance define your mass, that you are getting this resistance by the sand, and this sand is being generated by the particles of this sand. Now let's move one step further. This is the main idea of Higgs boson. In 1964, when Petro Higgs proposed his theory about the Higgs field, then the basic idea of Higgs field is like this. Imagine a space is filled with a substance, and that substance has a field. When you move particles into this field, then every particle feel a resistance with respect to that field. If you move electron into this field, then this electron is going to feel her resistance, and that resistance define the mass of this field, this particle. If you move a photon is a particle of light which is a less mass with respect to electron. When you move this electron and this photon, then you find that this electron is moving very slowly with compared to this photon. Why? Because photon is a less mass, and it will not feel that much resistance that electron is feeling. And the, according to this field, Higgs field, then those particles which feel a stronger resistant have a greater mass, while those feel a less resistant have a less mass. Now this field is homogeneous, it is same in everywhere, and it is isotropic, and it is universal, and our universe is filled with this Higgs field. Now let's move one step further, and the discovery of the Higgs field, that how this Higgs field was a good idea that Pietro Higgs proposed, or it was a false idea in the field of particle physics. This is the Large Hadron Collider. Large Hadron Collider is a highly sensitive and a big sensitive instrument which is built in by CERN in 1998, and 1998 it was completed, and it is a particle collider. What it does, it collides beams of proton approximately at the speed of light, that is 99.999 something percent, that collide the beams of protons. Now it is built in Switzerland. Its circumference is 27 kilometer. Now the function of this Large Hadron Collider, when the particle physicists use Large Hadron Collider to collide, to annihilate two beams of protons, then they get a shower. Here it is shown in this slide. When these particle physicists collide these beams of protons, then they get a shower of particles. From there they get quarks, leptons, and neutrinos, and different kinds of particles. And from there, then they saw in 1912, when they did this experiment, when they collide two beams of protons, then they saw that when they collided these two beams of proton, then a shower of particle created, and from that particle they saw that inside, from the center, a particle is generated, and that particle what they call the Higgs boson. It was the discovery of Higgs boson, that how the particle physicists used this Large Hadron Collider, and they collided these two beams of proton, and they get a particle. And now they wanted to know about this particle, and when they did more research on this, then they find that the Pietro Higgs was right. That is the Higgs boson particle, which is basically generating this shower of particle and providing masses to these particles. Now it was the time when they in 4 July 2012 they announced, CERN announced the discovery of this large that Higgs bosons particle, and it was discovered in this time, and they are now all shouting, and they are happy, and it opens new frontiers of areas in the field of particle physics, and especially in theoretical physics. Now there are some unsolved questions yet that scientists are trying to figure out about Higgs boson. That they are interested to know why Higgs boson has a small mass. Higgs boson has a mass, but its mass is smaller than the top quarks. Its mass is 125 gigawatt, and uh, its mass is similar as compared to the mass of top quarks. Now, now imagine that this field, this Higgs boson, which is generating, which is providing masses to the particle, but its mass is lesser even than those particles, then how it is possible? And this is one of the questions that particle physicists and theoretical physicists are burning their burning the candle with both ends, and trying to give the answer solution to this question. These are some often questions in the field of particle physics. Now the second question is, they are also interested that there maybe exist another bosons, Higgs boson particle, and if there are other types of Higgs boson particles, then what are they? And also they are trying to solve this issue in the field of physics. And the last question, that this Higgs boson is a spinless particle. It does not spin in clockwise or in anti-clockwise. It is not doing a spin, and it is a spinless particle. And how it is possible if a particle which is creating a isotropic and a homogeneous speed and providing masses to the particles in the standard model of particle, but itself is a spinless particle, and how it is possible? And it is a unsolved question in the field of physics, and they are trying to give the answer to this question. And it was my lecture, my today's lecture. I discussed the discovery of the Higgs boson and how Peter Higgs came with the idea of Higgs boson, and what are the unsolved questions in the field of particle physics that physicists are trying to figure out. I hope you got something from this lecture.